All right, hello everybody. Let's get started on this next section here. Here we're going to talk about volume and surface area. So we're going into the more three-dimensional shapes now. So instead of squares and rectangles and stuff, we'll talk about cubes and things like that and cylinders. So first off, we're talking about the volume of a rectangular solid. So when you think about the volume of something, you basically want to think of like how much would it take to fill it up? How much water would it take to fill it up? Something like that is what that's telling you. On the other hand, the surface area, which we have right here, the surface area, is basically like how much area there is on the surface of it. Well, no kidding. But it's more like if I had to go through and paint the whole thing, like it was a box, I had to paint the entire outside of the box, then how much paint would it take me to paint the outside, but not the inside? It's like just the hollow part. Okay, and so that's what we're looking at here. And typically for surface areas, you're just looking to add up all the areas of all the surfaces. The only place that doesn't really work is when you have a surface that's not exactly, a single surface that you could do before. So anyway, let's take a look. Let's start with here with the volume of a rectangular solid. And so I drew a little picture here for you, and it's right there. And basically it has a length, a width, and a height. And in fact, I think my L here kind of looks like a little E, so L, length, width, height. Length is this side here, width is kind of its depth, and then height is how tall it is. So it's those three sides. And to calculate the volume, you simply do length times width times height. So if you do length times width, you're basically going to get the area of this bottom part here, and then you're going to multiply that up through the height to take that up to fill up the volume of it. And so that gives you the volume right there. Okay? And for the surface area, what you're interested in doing is finding the area of each individual face. So I'll start with that face right there, and then this back face over here is exactly the same. So those two are the same, the front and back faces, which means I can simply find the area of the front face, which is length times height, which is that right there, and double it. I can then do the two side faces, this one over here, and then this one over here. You can't see, it's, but those two faces are the same, and they have an area of width times height. So that right there would give me those two faces. And if I undo that, then the last one I have is length times width, and that gives me this bottom face down here and this top face up here. They are the same, and so it's 2 times length times width. And so that's essentially adding up all the faces, the area of each face, and getting the total surface area of the whole thing. Next, coming over here, we have a special case of a rectangular solid, and that is the cube. And it's essentially the exact same thing, except in this case, the length, the width, and the height are all three the same thing. So we just label them with S for the side of the cube. And instead of doing, doing length times width times height, we just do S times S times S. And over here, we basically end up with 2S times S plus 2S times S plus 2S times S, which is 2S squared plus 2S squared plus 2S squared, which is the 6S squared we have right there. And that's where those versions come from. But you can always just use the rectangular solid versions to do a cube. It's just going to all reduce down to those right there. Next is the volume of a cylinder. In this one, you essentially find the area of either the top part or the bottom base of the cylinder. So we'd be finding this area right here. And since that area is the same the whole way down, we're just going to pull it down. Basically, that's the way I think about it, like I'm pulling it down through space and stretching it out by h, the height of it, and that'll tell me the total volume of it. So it's the area of one of the tops, just like with the rectangular solid, we did the area of the base and then multiplied it up through the height. We're doing the area of either the base or the top, so the area of the base is the same as the top, and then multiplying it up through there to get that. Okay? And so that gives us our volume of a cylinder. For the surface area of a cylinder, we have the surface area there and the surface area on the bottom. That is the 2 pi r squared, because that's the area of two different or two identical circles. And then after that area, what we have is the outer sleeve over here, this sleeve over here that goes around the front and the back. And you can imagine if we took that sleeve and we cut it down the middle, and then we had it and we were starting to roll it out like so, and we could essentially roll this out flat and we'd have a rectangle. And so what we would get is the length of the side of this rectangle here, this part right here, right, is essentially just the circumference of the circle on the top. So this would be the circumference of the circle, and then, let me undo where I wrote that green there, and then this would be the circumference of the circle, and then this over here would just be the height that's listed right there, the height of the cylinder. And then it would just be the area of that rectangle that we needed to find, which would be height times circumference. And remember, circumference is 2 pi r. So we end up with 2 pi r, the circumference, times the height. And then that gives us the outer sleeve of the cylinder as far as its area is concerned. Okay? After that, let me get rid of these extra marks I was making. If you need them again, just rewind the video and pause it and draw them. Here we have the volume of a pyramid. And for this one, it's pretty simple. It's just 1/3 the area of the base. That capital B is the area of the base, so this whole area down there. The area of the base times its height. And this is going to be true for all of our pyramids, not just these square-based pyramids, but all of them. It is 1/3 the area of the base times the height. So if you had a different pyramid, say it was a triangular base pyramid, something like this, then you'd find the area of that base and then times its height there, and then 1/3 of that. Okay, so that's how you find the area of or the volume of a pyramid. How do you find the surface area? Well, you're essentially just going to go through and add up all the faces that you have. So it's going to be whatever the area is of the base down here. In this case, it's the area of a square, plus the area of all the triangular faces. This triangular face, and this triangular face, and this triangular face back there, and the one on the back. So there are 4 triangular faces on this one, and so you'd go through and find the area of each triangle of those and put them all together. So that can be a little bit tricky, but you know, if you had like a 1, 2, 3, 4, 5, like say you had a pyramid like that or something, right? You'd have to go through and find all those faces, all these triangular faces like that, and add it to the area of the base down there. Okay, so it's different for each pyramid. That's why we don't have a single just equation there for it. Now for a cone, the volume of a cone is 1/3 pi r squared. So you see that pi r squared, that's the area of the base. And so now we can't just multiply that up through the height like normal. I mean, we do that as well, but we also have to take this 1/3, because if you think about it, if we just did pi r squared h, that would be the volume of a cylinder. And the cylinder is obviously larger. If I drew a cylinder on this, if I made a cylinder out of it, the cylinder has a larger volume than this pyramid. And so therefore, we have to actually go through and take this 1/3 in order to get the volume of the pyramid. Okay? It makes it smaller. And that specific 1/3, the only way I've ever seen it really derived is with calculus, so don't worry about where the 1/3 comes from. The surface area, on the other hand, can be a bit tricky. What you end up doing is, first off, the area of the base, right there, and then this next part here, which again is kind of complicated, you don't have to worry too much about it, tells you what the area of the outer sleeve right here would be. Okay, the outer part. I don't know if I did that very well, but this outer part that goes all the way around and on the back side as well. Okay, that's what that's going to tell you then the area of. So you put those two areas together and you've got it. Lastly, what I have here is the volume of a sphere. So this isn't just a circle, it's a sphere. Okay, And the volume is 4/3 pi r cubed. And the surface area is simply 4 pi r squared, okay? And so one tells you, how much it would take to fill this up. Say this was like you poked a hole in it and tried to fill it up with water or something like that. Then that's the volume it would take. And then the surface area would just be if you were trying to paint the outer part of the sphere. So one of the things you need to take a note of on all of these is for all the volumes, you end up with 3 lengths being multiplied together for each term. So L times L times L, so that would give you some sort of dimension like meters cubed. Whereas on the surface area, if you look at each term, you should only end up with 2 lengths multiplied together, and then you can add them up like in this case, and you'll end up with something like a meter squared or a centimeter squared or something like that. And that's true as you go through all of these. Here we have r squared, so that's like r times h times the h there, so that's length, length, length. So that gives us some sort of length cubed, meters cubed, centimeters cubed, or something like that. And if you look at each one of these, it's an r squared, so that's an r times r. And here's an r times h, so that's a length times a length. They're both length times lengths. So that gives us some sort of length squared, meter squared, or whatever. Over here for the volume, we have the area of the base, but the area of a base is going to be a length times a length. So that already starts as length times length, like in this case, length times width, and then we end up with length times width times height there, and we still end up with some sort of 3 sides being multiplied together and giving us a volume measurement with something like a meters cubed. For the surface area there, you'd still end up with a bunch of meters squared here. R squared in h, so that's r, and then h, so that gives us the 3 sides. This one down here, r squared, that's 2 sides. And then over here we have an r squared and an r squared, right? But we're taking the square root. So the square root of a side squared is just that side. So underneath that square root, we end up entirely with just a single length. And so that's 1 length times this other length right there. And that's a length times a length and gives us a length squared. So like a meter squared or something like that. So for all of these, this works. And especially if you come down here for volume of a sphere, r cubed, there's our 3 lengths, r times r times r. And then r squared, there's our 2 lengths, r times r for the surface area. Okay, so keep that in mind. Make sure you're familiar with these formulas here, and of course then be able to use them. So let's take a look here, and we'll try a couple of these, and then I'll leave the rest for you to try, which I think over on this page is an answer key, so you can check your work. So I'll do maybe the first. Maybe I'll do number 2 for you and then let you work on the rest. So this is a pyramid. If you look back, you remember the volume of a pyramid was right here, and it's 1/3 the area of the base times the height. So if we come back over here, we say volume is 1/3 the area of the base times the height, right? Just like we saw right there. And then we start plugging this in. So this is 1/3. The area of the base is going to be 6 centimeters times 4 centimeters. And then, I'll zoom in on this a little bit. And then the height, you can see is pointed to right there, is also 6 centimeters. And so we end up with 6 times 6 times 4. So 6 times 6 is easy. That's 36. And then times 4, and then over 3. And I'm doing it this way just because, and then of course centimeters, centimeters, centimeters. I'm doing it this way because I noticed that 36 being divided by 3 is pretty easy. I could have even just done 6 divided by 3 right off the bat, but 36 divided by 3 is just 12, and then 12 times 4 is a lot easier than 36 times 4, and so I'm just rearranging the order, and so that's going to be what, 48 cubic centimeters. All right, the other way I would have ended up with 6 times, what is that? 6 times 8, which is also 48. Okay, so there we go. We ended up with the answers we were looking for there. And That's the answer for that one. So I want you to go through and try working on these ones here, see if you can get them solved, find all these volumes, and then when you're done, check your answers on this next page. Make sure you got these answers to match up. Okay? After that, the only thing left here is this last page, which is doing some surface areas. I'm going to let you work on these. I might do this first one for you. It tells you the surface area of a rectangular solid whose height is 2 feet. So if we draw this in, this is 2 feet is the height. Its width is 10 feet, so very big width, 10 feet. And it's, finish drawing that, and its length is 4 feet, okay? So not perfectly to scale, but something like that. And so they ask, what is the surface area? So for this one, surface area, if we go back here, if we go back over to this one, we can see this was our equation for surface area. So I'm just gonna actually grab it real quick and copy it, take it with us, copy. So we come back over here to this one, and there it is. This is our surface area right there. And so we're gonna go through and do that. And so this is gonna be, get my pen here, 2 times the length times the width. So the length is 4 feet, and the width is 10 feet. And then plus 2 times the width, which is 10 feet, times the height, which is 2 feet, right? Zoom in here a little bit. Plus 2 times the length, which is 4 feet, times the height, which is 2 feet. There we go. And so this becomes 2 times 4 times 10. So 2 times 4 is 8, times 10 is 80 feet squared, plus 2 times 10 times 2. Well, 2 times 2 is 4, times 2 is, or times 10 is 40 feet squared, plus 2 times 2 is 4, 4 times 4 is 16 feet squared. And that'll ultimately give you 80 plus 40 is 120, plus another 10 is 130, plus a 6 is 136 square feet, just like that. Okay, and then you can come over here and check, and yep, that's the answer we were looking for, so we got that one right. The only other thing I'm going to say about these is be very careful. In number 3, it asks you how many square feet of wrapping paper will be needed to cover the box, but it's giving it to you in inches. So you're either going to have to convert the inches into feet before you multiply them all together to get the volume or to get the surface area, or you're gonna multiply them together, add them all up and everything, and get the surface area, and then convert to square feet. That second way, converting to square feet after you already multiplied these together, is a little bit trickier. It can be faster, but it's a little bit trickier. I would just do it ahead of time by noting that 12 inches is 1 foot, and then 36 inches, well, there's 12 inches in a foot, so 36 divided by 12, that's 3 feet, and then I'll let you figure that one out on your own. But I would make them into feet first, and then go through and do the multiplication and additions for finding the surface area. And then this last one, use the formula that I gave you back on that first page and figure those out. And again, check your answers when you're done. All right, that's pretty much it for now, and thanks for listening.